Hey guys, it's Mike. Time for another suggestion. Again, when this one was suggested, I forgot to ask for permission, so keeping with my promise, I'm not going to throw anyone in the spotlight who may not want it. So I'm just going to say this one was suggested by a friend when I posted one of the earlier episodes. Their suggestion was that they wanted to know my thoughts about time travel. Um, That's actually a really interesting topic. I find it very interesting, and I don't necessarily think it's as complex of a concept as people make it out to be. Um, at least not from a physics perspective. Figuring out how to do it is a completely different question. We haven't figured that out yet, or have we? No, just no, just kidding. We haven't. At least as far as I know. So let's start with um, defining time travel, right? Now, traveling through time is something we already do. We all do it. We all travel forward in time at a constant pace. It is now 1 minute and 30 seconds since I started recording. I cut a bit out of the middle in case you thought, or sorry, I cut a little bit out at the beginning in case you were keeping track. So we all travel through time already. Time travel is not something that needs to be invented because it's something we already do. The issue is the rate and the direction. Much the same way, going back to high school physics, there's a difference between speed and velocity, right? Speed is something like 20 kilometers an hour, or for those who don't use the metric system, let's say 20 miles an hour, right? So that's a speed. We have a rate of travel, but a velocity is very, very different. Whereas a velocity is more 20 kilometers per hour south, right? So velocity is both speed and a direction. Well, I guess it's not all that different. It's just kind of more of an add-on, right? Because you can go 20 kilometers an hour in a lot of directions. You can go 20 kilometers an hour straight down at a certain point if you fall out of an airplane. um, you can go 20 kilometers an hour south, north, east, west, up. You can go all kinds of directions at 20 kilometers an hour. So 20 kilometers an hour south is the velocity. So that's the same um, change we have to make to our concept of time travel. It's not that we need to figure out how to travel in time. We already do that. We need to figure out the velocity. Because right now, this is a total tautology, but right now we are time travelers at a rate of 1 second per second. We go 1 second in time forward every second. Like I said, total tautology, but I mean, with the fact of the matter is we already travel. It's just a matter of we. What the question is more regarding is how do we change the direction or how do we change the speed? So let's start with speed. Following my understanding of Einstein's theories of relativity and a couple of other theories, basically, one of the theories that Einstein posited was that the closer we get to the speed of light, the slower time travels for us. And this is, as far as I know, been proven to be true. Um, if you're driving in a car at 100 kilometers an hour, time is actually traveling slower for you than it is if you were just walking down the street. Um, the only the only reason that doesn't cause all kinds of you know scheduling conflicts is that a difference of 100 kilometers an hour, it causes such a small difference in time that it is A, imperceptible, and B, irrelevant. But it is there. Um, so there's that. So theoretically, if you wanted to go forward in time, like keep the same direction in time that we are already traveling, but you simply wanted to go there faster. You wanted to be able to jump 100 years into the future. All you need to do is go fast, right? The faster you go, the slower time goes. So the world continues around you, but time is slowed down for you. So when you slow down physically, in terms of velocity, when you slow down, you will revert. Your travel of time will go more in line with the rest of the world, and so what may be like a blink of an eye to you may be 300 years to everybody else. So yeah, you want to change the speed of time? Just go fast. If only it was that simple. Of course, it's exponential. So the closer you get to the speed of light, as you approach the speed of light, time approaches, but never quite hits zero speed. So time still travels for you. It's just very, very slow. Slowing the rest of the world down is a completely different matter. You just need to be going slower than everybody else. But given that your speed of all that kind of thing is kind of determined by being on the planet Earth, it's kind of hard to make the rest of the world go faster than you. So that I don't know. So from a physics perspective, there's that. That's something that we already kind of understand. The other thing that can affect the travel of time is gravity wells, right? As far as I understand, because gravity is not just two objects pulling together like they teach you in high school or junior high. Do they teach that in elementary? I don't know. Anyway, gravity is not just two objects, and the bigger object pulls the smaller object towards it. The analogy that I is used very frequently, and this is a dramatic simplification of the concept of gravity, is if you imagine space as a mattress, right? Pretending for the time being that space is two-dimensional. It's just a single plane. Space is a mattress. You have a bowling ball, that's a planet. Put it on the mattress, it causes a dent in the mattress. If you were to put a golf ball, say a moon, near the bowling ball, the dent in the mattress pulls the golf ball closer to the bowling ball. From what I understand, the same effect actually applies to time. So the mattress isn't actually just space. The mattress represents space-time. So in much the same way, like a high mass object, like a bowling ball, creates a dent in space, it also creates a dent in time. So, if you were to be stuck in the gravity well of a large planet like Jupiter, time would actually go slower for you than it would if you were stuck in the gravity well of a smaller planet like Earth. And of course, the greatest gravity wells are black holes. So if you were to be stuck on the event horizon of a black hole, then time would slow down greatly for you. And the rest of the galaxy would keep on going, and you would just kind of catch up for it if you ever managed to escape the event horizon of a black hole. If you don't escape the event horizon, or if you pass the event horizon, of course you're sucked in by the black hole and it doesn't matter. But if you are able to escape, then you would catch up with the galaxy currently in progress. Anyway, so those are the two things as far as that can slow down time, is either A, going very, very fast, or B, being stuck in a massive gravity well. So let's ignore physics for a little bit. Let's just assume we figure out some way to travel in time, or change the speed of travel in time, that does not involve either turning the gravity to 11 or going really, really fast. So let's assume there's some scientific or technological advancement that we just haven't come close to conceptualizing yet, that allows us to change the speed of time travel. Let's now focus on the direction of travel, because we're all traveling forward in time. That part's easy. What about traveling backwards? I think, the classic example is, what if you go back in time and kill your father or your grandfather or what have you, right? Then you'd never been born, so you would never have existed to go back in time to kill your father, so you would have been born, so blah, 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 blah. It's a classic time paradox. You've created a time paradox. But I don't think that's actually as much of a risk as science fiction would have us think it is. Because anything you've already done, or anything you would do if you go back into the past, has already happened. Make sense? I believe from your starting point, it is infinitely possible to change the future, but infinitely impossible to change the past. So, say you go back in time and let's say you attempt to go back in time to kill Hitler. It's the classic, time travelers. What's the first thing you do if you could go back in time? Obviously, kill Hitler is what a lot of people think of. From my theories, my ideas of time travel, there's a few possible outcomes. Let's say you successfully are able to go back in time and attempt to kill Hitler. Either A, you succeed. You do kill Hitler. The only thing is, the way you managed to kill Hitler is what actually happened at the end of World War II. You were just the cause of it, and you didn't know that. So you unknowingly cause things that you know to be true already, right? We know Hitler dies at the end of World War II. In the bunker, Eva Braun, suicide pill, yada yada yada, is the story. So maybe you go back in time and try and kill Hitler, but as it turns out, the way you kill Hitler is the suicide pill, right? This is what's already happened. You can't change what's already happened. You just cause that to be the thing that happened, and you just didn't know about it before. The other possibility is that you fail. You do not succeed in killing Hitler. You either attempt it and get stopped, or you just don't manage to make an attempt in the first place. Those are the three possibilities, right? Either you succeed, but the way you succeed is what happened already, or you fail either because you attempted and you didn't succeed, and it was an unsuccessful attempt, or you just never get around to attempting it in the first place. Go back and try and save the dinosaurs, you accidentally end up wiping them out because of the meteor or whatever. Things like that, right? Whatever you would do in the past has already happened. So therefore the bridge would be not you changing what happened, but you changing your understanding of what happened. I went back to try and do this. As it turns out, that had already happened, and this is the result instead, right? It's not that you managed to change the course of history. You just didn't know that you were part of it. Or you, as it turns out, you're not part of it. You failed, right? So I believe it's not possible to change the past. You can go back and spectate if you like, but you can't change the course of history. On the other hand, something you do in the past might not actually have noticeable effects until after your start point of time travel. With the butterfly effect, like chaos theory, right? You accidentally step on a butterfly, and while you're in the past trying to kill Hitler, and as it turns out, that butterfly, through a long series of chain of events that escalate in scale, would eventually cause the invention of quantum computing in 2050. You started in 2013, let's just say this year, right? You started in 2013, and because you killed that butterfly in the past, they will never invent quantum computing in 2050, right? So from your starting point, the future hasn't happened yet. You can do things, or you can set things in motion that will affect the future because it hasn't happened yet. But the past has happened. Um, so you can't change the past. You can only change the future. That's true, time travel or not. So that's my thoughts on time travel, and the ability to affect the timeline. The other thing that a lot of people often forget about is the fact that the Earth doesn't stay still, right? The Earth is spinning on its axis at a very, very fast rate, actually. This is not perceptible to us because it's the constant, right? So the Earth is spinning on its axis. If you were to jump 5 minutes into the future, you would not be in the same physical location. If you kept the same physical location in space and just jumped 5 minutes into the future, the world would have spun and left you behind. 5 minutes, a lot changes. If you start in, let's say you start in New York, if you jump 5 minutes into the future but keep the same physical place in space and time, you're like in Midwest, but maybe not quite that much in 5 minutes. But you're not in New York anymore. So because the world spun and you've just stayed in the same spot, New York has moved away from you. So, and that's just the Earth spinning on its axis. You have to remember the Earth is also spinning around the sun, and it's spinning around the sun faster than it's spinning around the axis. You also have to keep in mind that the sun is not standing still. The sun is spinning around the center of the galaxy, even faster than the Earth is spinning around the sun. And the galaxy is moving even faster than that. I mean, the numbers as to the speeds and velocities at which we are actually traveling through space are so ridiculously high, most people can't conceive them. We are traveling incredibly fast all the time, and we just don't notice it because it's all relative, right? What we see, what we can perceive, is the walls around us, that tree on the corner, the car on the street. We can perceive that. We cannot perceive the sun spinning around the galaxy's core. We can't perceive that. That is at a scale so far beyond our own. We cannot, the average human cannot fathom it. We cannot understand it. We can understand the concept. We can understand the theory. We can understand really, really big. Actually, if you want a really interesting video on how we conceive numbers, do a search. It's on YouTube for Penn and Teller Explain Numbers. It's just a short video. It's like 3 minutes long or something like that, and it explains how the human mind conceptualizes numbers. And it's a really cool, strong profanity, fair warning, in that video. But it's a very good layman's terms description of how humans understand numbers. So, keeping in mind that the Earth is spinning, and the Earth is spinning around the sun, and that the sun is spinning around the galaxy, and that the galaxy is moving, and the rate of motion is just getting so much higher and higher and higher every time you jump a scale. You jump 5 minutes into the future, but keep the same point in space. You're lucky if you're within the radius of Pluto's orbit. Like, you find yourself in the cold vacuum of space, which actually isn't cold, but we'll get into that in another time. It's not anything. So I'm going to leave it there. Final thought before I leave it there. So time travel isn't just traveling in time. In order so that you don't die because you materialize in the middle of the vacuum of space, you also need to travel relative dimensions in space. You see what I did there? Yes, you need to do travel in time and relative dimensions in space. You need a TARDIS. Um, so I'm going to leave it there for now. I'll talk to you later. Bye bye.